Okay, guys, so we got a quick video here today. Of course, Mr. Phil here with Math Made Easy. We're just going to be talking about multiplication and division with negative numbers. Now, I want to tell you that there are a couple rules that um, distinguish multiplication and division of negative numbers with addition and subtraction. But a great way to look at division and multiplication with negative numbers is that you're going to follow all the same rules that you would have previously with any multiplication or division operation. It doesn't matter if you're using integers, if you're using fractions, or decimals even. We're going to be talking about how to evaluate them. So let's get started. So on the left side of this illustration that I have here and what I wrote down, I want you to take a look at this chart where on one side it says given and one side it says answer. So what you're going to do is read this chart as such. If you see two positive numbers together, you are going to get a positive number. If you have a positive and a negative, or a negative and a positive, it doesn't matter which order you get it in, you're going to end up with a negative answer for both. So if there's one positive and one negative, the answer is negative. And lastly, if you have two negatives that are multiplied or divided together, you're going to have a positive. So that's it. Those are the rules for multiplication and division. That's how you know whether or not you have a positive or negative answer. So it doesn't really matter what the values of the numbers are. With addition and subtraction of negative numbers, we had to pay very close attention to the values of the numbers, which one was bigger, so on and so forth. But for multiplication and division, we don't really care. And just to put a side note on this, I wrote up here in yellow, even is positive and odd is negative. So that's going to apply to all the problems that we're doing here, but it's also going to apply to exponents later. And what I mean by this is if you have an even amount of negative signs, like 2, 4, if you have 6 negative signs, where the only operations we're doing are multiplication and division, then your answer is going to be positive. The same thing works for an odd number of negatives. If we're only doing multiplication and division operations and we have an odd number of negatives, then the answer for that problem is going to be negative. So just to recap, it's very important you understand this rule of even or odd negatives only applies if we're doing multiplication and division. So if you have a order of operations problem with parentheses and brackets and all sorts of different numbers and operations, if you have a section or a parenthesis or a bracket where it's all multiplication or all division, for that part you can use this rule of even or odd negatives. But of course, like I said, once we start throwing addition and subtraction in there, then we have to start paying attention to value. So let's take some of these rules and just see how we can put them into practice. Like I said, on the right side here with the purple problems, we're just going to do multiplication like normal. 2 times 3 is 6. And here we have a negative and we have a positive. Remember, if there's no plus written, that it's implied positive. So in our chart here, we have a negative and have a positive, which means our answer is going to be negative. So the answer is negative 6. We got to write the negative, of course. If you want to use the rule from the yellow writing up above, we can do the same thing. 2 times 3 is 6. There's only one negative there. So since 1 is an odd number, our answer is negative. Pretty straightforward. Let's do the second problem. 4 times 5 is 20. And again, we only have one negative in the problem that's attached to the 5. So the answer is negative. Now, I wrote these problems like this on purpose so that you could get used to seeing one important idea that you'll come across when you're doing exercises like this. And this is when we put parentheses around a number just to signify that they're negative. So you won't see this typically around numbers that are positive, like you won't see plus 2 in parentheses times 3. And that's because, like I mentioned before, anytime there's no positive or plus sign written, it's implied. So just like I wrote down here, or in the next problem, this problem is really telling you to multiply negative 6 times negative 11. We don't have an x in there, and we don't have a dot like I drew up here, which is a symbol we use to replace the x for multiplication just because in later concepts and more difficult and challenging math, we're going to use variables, and x is probably the most commonly used variable in math. So it just doesn't make sense to mix that up with multiplication. In textbooks, they try to write the x in like a more cursive looking font, but it's very easy to mix up when you're writing by hand, so the dot replaces that. But we can also put two parentheses together like this and understand that they're telling us to distribute the -6 to the -11. So let's do that really quickly. 6 times 11 is 66. And since there are two negatives, or we have negative, negative, the answer or result then is plus. So the answer for this is positive 66. We can write the positive there, but like I said, we don't have to. So now if you look at the last problem here, we have some fractions. And like I said before, we can use the same ideas when we are doing fractional work with negative numbers and multiplication and division. So I'm going to keep the -3/2 in a parenthesis like this, just so I remember it's -3/2. But I'm going to replace this division with multiplication because I'm going to invert the 1/4 and use the reciprocal of 4 over 1. So I'm going to go through and look for cross multiplication or cross reducing, cross canceling, whatever you want to call it. And then I can multiply. 3 times 2 is 6 over 1 is 6. Now let's count the negatives. There's one negative, or if we use the chart, it's a negative positive problem because 3/2 is negative, 1/4 is positive. So the answer, therefore, is negative. So the answer is -6. And that's pretty much it, guys. There's not much more to this. It doesn't matter if there's 10 numbers in the problem, if there's only 2, you're going to use the same rules. If you want to count up all the negatives at the end after you've multiplied or calculated, or count them up at the beginning, it's completely up to you. Obviously, the key here is you just want to keep track of how many numbers you have. So just to recap the multiplication and division rules, if you have an even amount of negatives, then the answer is positive. If you have an odd amount of negative signs, then the answer is negative. And of course, these rules only apply when we're using a mixture of multiplication and division, or we're only doing multiplication and only doing division. This chart that I wrote here on the left-hand side is a chart you can use for every type of multiplication and division problem with negatives. If you have two positives, the answer is positive. If you have a plus and a minus, or a minus and a plus, the answer will be negative. And if you have two negatives, the answer is positive. And just a last thought for this section, another way to think of this chart is negatives always win in a battle. So anytime they go up against a positive number, they win. The answer will be negative. The only time that negative loses is if it goes against itself. So a negative and a negative, they lose to each other and therefore form a positive. And of course, a positive and a positive just stays positive. So I would say go and do some problems and exercises to practice these ideas and see if you can get the answers right. In the next section of this video, I'm actually going to go over how exponents work with regards to multiplication and division of negative numbers. It's basically just an extension of this even and odd rule. Okay, guys, well, I'm having some technical difficulties, and you can see I already wrote down a lot of the steps here. That's because I went and recorded the video of this the first time, and when I tried to save it, it wouldn't save, and it kept on telling me I couldn't open the file, so here we are. I'm going to quickly recap how you work with exponents with negative numbers. So in the earlier part of this video, we talked about how to work with multiplication and division. You can see I left the same chart up here, and I left the same information about having even amount of negatives and having a positive answer, having an odd amount of negatives, ending up with a negative answer. So let's go into a bit about how to use that when you have multiple numbers. I wrote a problem here with 1, 2, 3, 4, 5 different numbers. Also remember how I mentioned before, in between parentheses, if there is no sign, you're going to assume that they mean multiplication, and then in between these I wrote a division sign. So we have two different operations here. So what I did is I looked at the 2 and the 1/2, and because they're all multiplication and division, it doesn't matter what order you go in, I cross-canceled these. Then I did 3 times 4 is 12, and then divided by 6. So the answer for that part is 2. Now this is where the negatives come into play. Remember how I told you you could count the negatives at the beginning or you could count them at the end. I personally like to count them at the end because sometimes I forget to do it in the beginning. So here I have one negative and I have two negatives in the problem. If I have two negatives, that's even amount of negatives. That means my answer is positive, and that's why the answer from this problem is positive 2. It's that simple. You calculate, and then you see how many negatives there are, and then you choose the answer based on how many negatives there are. Remember, again, this only works with multiplication and division. So now we're going to talk about exponents, and I want you to go to the left part of the screen down here in the bottom where I wrote 2 to the third power. That's how you want to read exponents. This 3, the superscript to the top right of this base, tells you that what you need to do. In an exponential problem, what you're doing is taking the base, which is the bottom number, and you're doing a very specific type of multiplication problem. And the multiplication problem we're going to do is we're going to take this base and we're going to multiply it by itself however many times the exponent tells us. So what I wrote over here is exactly what you need to do. The base is 2, and we need to write it 3 times. So 2 times 2 times 2. There's 3 3's. I'm multiplying them out. So 2 times 2 is 4. 4 times 2 is 8, so the answer is 8. That is how exponents work. There's nothing else to them as far as calculating them, so you just need to understand that the base is the number we're going to write however many times the exponent tells us to, and then to calculate, we're just multiplying. So where do negatives come into play with this? Well, it's the exact same thing as we learned before, because if an exponent problem is a very specific type of multiplication problem, well, the same rules for negatives apply. So here's a very important distinction that I want to show you though, and it's almost more of a notational thing. So when I have a number like this here, negative 2 to the second power, what that means is I have a negative 2 times itself twice because the power is 2. Like we mentioned over here, with the same basic fundamental idea here, where it's a negative base 2 squared, but no parentheses anywhere. You're actually supposed to assume something different, and that's because of the order of operations. In the order of operations, PEMDAS, P-E-M-D-A-S, P stands for parentheses and E stands for exponents. So if we do not have any parentheses in this problem, the first thing we need to do in the order of operations is address the exponent. So what does that mean? I drew a little arrow here to show you how you are supposed to interpret this specific problem. You are supposed to think of it as positive base 2 squared, and then you calculate the negative later. Remember, a negative on the outside is also the same thing as negative 1 times whatever quantity or value is inside the parentheses. So if we do 2 squared, 2 to the second power is 4, and then you put another negative with a positive 4, and the answer is negative. Or, like we've done before, if you look in this problem, there's only one negative here. That is odd. So that means our answer is going to be negative. Thus, we end up with an answer of negative 4. You're going to notice any problem where we have a positive base but a negative on the outside without a parentheses, our answers are all going to be negative. Why? Because we only have one negative. So if we always have one negative in these type of problems, that means we're always going to have an odd amount of negatives, which means our answer is always going to be negative. But if you look down here, this is where it changes. We're saying negative 2 to the third power means there's 3 negative 2's. And if there's 3 negatives, that means there's an odd amount of negatives, which means our answer is negative, and that is why the answer is negative 8. Very quickly, if you have a fraction exponent, all the same rules for negatives will apply. The only difference is with a fractional base, you're going to put the exponent both to the numerator and you're going to put it towards the denominator. So to evaluate, you want to do 1 squared, or 1 times 1, which is 1. And then you're going to do 4 squared, or 4 times 4, which is 16. There are no negatives here, so that means our answer is positive, and our answer is 1/16. It really is that simple. Of course, there are going to be many variations to the types of problems you can do. They can get more complicated by adding more numbers in there. I shouldn't say adding, by making you multiply and divide more bases and exponents and more numbers with negatives and fractions and decimals. But as far as the negative numbers are concerned, these are the only rules that you need to know, and this is how you can apply them to your answer to make sure that the answer you get is correct. Because even if you get the right integer value, if you write down +2 but the answer is -2, that is very clearly wrong. So I hope you can take these ideas and tips and put them into use. Of course, I wish you the best of luck, and as always, I am wishing you well. So until next time, I will talk to you soon.